I'm Mr. Craig, and I want to work out the even questions for balancing word equations, or balancing word chemical equations. So let's go right to the questions. So question number 2, and again, just like from the examples, be sure that we actually change this into the correct chemical equation. And what that means is we need to change the word form into a chemical formula, if that's what it was looking for. So aluminum bromide, so again, aluminum is this, bromide is Br. So when looking at your periodic table, you know that aluminum has a +3 charge, bromine's a -1, so we need to balance this. So we need to balance out the charges because these are ionic compounds. The and means that we have a plus sign. Chlorine gas, so again, since that ends in ine, if it ends in ine or gen or ine, then that means it's diatomic when it's by itself. So chlorine, and don't worry about the gas component on there, or if it says metals or liquids or whatever, that's just a distractor more than anything else of what the question's doing to you. Yields is an arrow, and here we have aluminum chloride. So we'll put the chloride there. Again, aluminum has a +3 charge. The chlorine is in group 7A. Looking at your periodic table, that's a -1 charge. So that means that we need 3 chlorines. And yields liquid bromine. So bromine, again, ends in ine, so that means that we have 2 of those. Make sure that you remember that if it ends, the element ends in ine or gen, so like hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, all those things, if it ends in ine and gen and it's by itself, it must be diatomic. I will expect you to know that. So be sure that you have that memorized, since we had talked about it before. All right, so now that we have our equation written out correctly, let's focus on the inventory. So we have one aluminum, or actually we have aluminum, we have bromine, and we have chlorine. Over here, let's put it in the same order. We have aluminum, bromine, and chlorine. Now let's get our numbers. So we have 1 aluminum, we have 3 bromine, we have 2 chlorine. On this side we have 1 aluminum, we have 2 bromine, and we have 3 chlorine. So it looks like in this case the aluminum is quite happy, so let's focus for now. Let's focus on the bromines. Here we have 3 and we have 2, so that means that we need to, let's get that to 6. So I'm going to multiply that by 2, and I'm going to multiply this by 3. So in that case, my bromines look good, but let's fix the aluminum since we have a 2 there. Okay. And since I now have 2 aluminum on this side, let's put a 2 here. So we got 2 aluminums, which also changes my chlorine to 6. And everybody looks the same except for chlorine. Put a 3 there, and you're balanced. Now, you may notice that whenever I write a coefficient, I always write a number underneath. You don't have to do that. I do that just so it sticks out a little bit better. And I know that there's different colors up here, but you don't have different colors. So writing a line underneath kind of helps. It'll help you to keep things organized, and you won't think that something's a subscript or something else. But again, that's just me. All right, so let's look at number 4. Number 4, potassium chlorate when heated yields potassium chloride and oxygen gas. So potassium is K, the chlorate is one of your polyatomics, ClO3, and potassium has a +1 charge, chlorate a -1 charge. When heated yields, that's arrow, potassium chloride, so KCl, and again, potassium's +1, chloride is a -1, and oxygen gas, so O2. So again, setting up or looking at your inventory, potassium, chlorine, and oxygen, potassium, chlorine, and oxygen, and we have 1 potassium here. Let's get that up. We have 1 chlorine here and 3 oxygens there, 1 potassium, 1 chlorine, and 2 oxygens here. So again, your potassium chlorines are the same at this point, so we have to go right to the oxygen. Since we have 3 here and 2 there, let's go ahead and Balance that out. So now that gives us 6 oxygens, but also it gives us 2 chlorines, I'm sorry, 2 potassiums and 2 chlorines. So, and we have 6 oxygen on this side. So to balance that out, put a 2 right there. All right, number 6. Calcium hydroxide. So calcium, Ca, and hydroxide. That's, even though it ends in IDE, that's one of our polys. So hydroxide. And remember, calcium, since we're looking at calcium, calcium's in group 2A. So calcium's +2. Hydroxide has a negative, very good, 1 charge. So that means we need 2 of those. And, means a plus sign. Phosphoric acid, now that's not one of your things that you should know, and I probably should have told you what that was. The phosphoric acid is H3PO4. We'll learn about phosphoric acid and the other acid names near the end of the semester when we get to acids and bases. So I'll tell you what the acid names are at this point. React to form, that means arrow. Calcium phosphate, okay, so calcium, and then phosphate is one of your polys. So make sure you remember the charges. Calcium's +2, phosphate is a -3, very good. So that means that we need 3 of those and 2 of those, and water. So water. Okay. Do we have any polyatomics? Actually, we have 2 polyatomics. If you want to learn how to write water correctly in AP Chemistry, this is how we write water, where you have a hydrogen and a hydroxide. Now, you don't know that yet, but I'm telling you right now. So here, we actually have a poly here, we have a poly here, we have a poly here, and we have a poly here. So that makes it nice. All the nonmetals are polyatomics, which makes this an extremely easy problem to balance out. Or you can do the inventory and do it the long way, but that's your call. So I've got calcium, I've got hydroxide, I'm going to leave it as a poly. I have hydrogen, and notice that hydrogen and hydroxide, 2 different critters here, and it'll make it a lot easier for you. Phosphate, and don't write the charges, so let's keep it in the same order. So calcium, hydroxide, hydrogen, and phosphate. Now the reason why I showed the hydrogen separate, because this is a nonmetal, this is a metal, so I'm going to treat it like that. All right, calcium, 1. Hydroxide, I have parentheses around that, so there's a 2. Hydrogen, I have 3. Again, I'm not using these hydrogens for that. That's a metal, that's a nonmetal, 2 different critters. Phosphate, no parentheses, so there's 1. On this side, I have 3 calciums. Hydroxide, no parentheses, there's only 1. Hydrogen, there's only 1. Again, metal, nonmetal, 2 different critters. Treat them differently. Phosphate, I have 2. Okay. All right, so calcium, I have 1, I have 3, so let's put a 3 there. That gives me 3 of those, and now I have 1 times 2 times 3, which is 6. Okay. So that means I need 6 hydroxides on this side, so I'm going to put a 6 there. So 6 times 1 is 6. Now I have 6 times 1 for the hydrogen. I have 6 of those. Again, I don't have a total of 12. I do have a total of 12 hydrogen, but I'm not looking at it that way for the sake of speed. Which means that I now need 6 hydrogen on this side. So if I put a 2 there, oops, there's my 6 hydrogen, which also changes my phosphate. Again, no parentheses, so 1 times 2 is 2. We are balanced, and trust me, that was twice as fast as if we would have broken down and looked at each element separately. But again, however you want to balance is fine. Just make sure that you have the equation written out correctly, each of the formulas are written out correctly, and you have the correct coefficients. Now again, if you put a 1 there, try to get out of that habit. You don't need a 1 there. All right, let's look at the last one. Okay. Number 8 says hydrogen. There we go. We got a gen in there. So we have hydrogen and nitrogen monoxide. So nitrogen monoxide. Since we have that mono in there, that means that we're not balancing charges. Besides, we have a nonmetal with a nonmetal. Okay. Reactive form, that's an arrow. Gaseous water, solid water, liquid water, it's all water. So H2O, or HOH if you wish. And nitrogen gas, there's that Gen again. So N2, okay? So let's do our inventory. Hydrogen, nitrogen, and oxygen. That's all of them. Let's do the same thing over here. Hydrogen, nitrogen, and oxygen. So over here I have 2 hydrogen, 1 nitrogen, 1 oxygen. Over here I have 2 hydrogen, 2 nitrogen, 1 oxygen. Okay. Hydrogen looks good for now. Nitrogen, I have 1 here, but I have 2 over there, so let's put a 2 there. And now that gives me 2 oxygen. So now I need to get 2 oxygen over on this side. So put a 2 there. By doing that, I did that. So now I have 4 hydrogen. So 2 times 2 is 4, 2 times 1 is 2. So now to get my 4 hydrogen, put a 2 there, and I have 4. And it looks like everybody's balanced. Now, we cannot reduce these values down because that is a 1. All right, so again, emphasizing, make sure that you know your 52 elements, your polyatomics, and that you can still write your chemical equations. So what that may mean is that you need to go back to last semester's work and look at how to write chemical formulas. We'll be doing that all year long.